Hi, my name is Brianna Poon, and this is my report for Lab 3, Black Hole for Physics 2211, Section B in Georgia Tech. So the purpose of this lab is to analyze a star's motion as it orbits around a black hole and find the net force acting upon it, and then use that information to estimate the mass of the black hole. And then also determine the initial velocity that a spaceship must have when leaving the surface of a planet very close to the black hole. And the objective is to fly around the black hole without crashing on the planet or into the black hole. So the fundamental principles at work here are Newton's second law, which states that F net is equal to change in momentum over change in time, which is also equal to the sum of F net perpendicular and F net parallel. So F net perpendicular is the force orthogonal to the direction of motion, and it changes like the direction, so it like turns the motion. And then F net parallel is in the direction of motion and changes the magnitude of momentum or the speed. And then some other formulas that I use were the velocity and position update formulas, as well as universal gravitation. So the assumptions in place here are that F net is equal to the force of gravity, and this is because in space the only forces present are gravitational forces acting on whatever the system is. And in part one, the system was the black hole, and the surroundings were the star. And in part two, my system is a spaceship, and the surroundings are the planet and the black hole. So here are my initial conditions for part one. So we have the gravitational constant here, the mass of the star, delta t, which is just like 1 day in the length of seconds. And then here's my actual code for part one. So what I did was I calculated the initial momentum and final momentum, used that to calculate F net using dp/dt, and then also use that F net to calculate the parallel and perpendicular components. And then using that, I was able to calculate the mass of the black hole using the gravitational force formula. So here's the result that I got from part one. The mass of my black hole was 1.31 times 10 to the 34th kilograms. And we also have the magnitude of the forces here. And then using that mass for the black hole, I was able to set my initial conditions for part two, where again, my system is a spaceship and surroundings are the black hole and the planet. So we have the mass here, other constants here. And then down here is where I input in my velocity that I'll need for my ship to like kind of get close to the black hole, but not be pulled into the orbit or like crash into the planet. And this was determined through trial and error. So here's the actual code for part two. So what I did here was calculate the net force on the planet by adding up the force from the black hole on the planet and also the ship on the planet, and did a similar calculation for the force on the spaceship. And then using the F net, I was able to apply the velocity and position update formulas to get an actual like visual of what the movement looks like. So here's the result from part two. Again, this is the initial velocity that I calculated through trial and error to get this position as close to the black hole as possible, while also being able to like leave orbit and not crash into the planet. So some error in my calculations. For part one, the mass was actually an average of multiple calculations at multiple points. So to make it more accurate, I could have just like run the program for longer. And for part two, because I used like the rounded mass of the black hole, there could have been some propagation of error there. And also I did calculate initial velocity through like guess and check. So like there could have been like a better way for me to calculate a more accurate velocity. So how are the net force and its parallel and perpendicular components different from the rate of change in momentum and its parallel and perpendicular components? So numerically, these two things are the same. So this raises the question of why we use dp/dt instead of F net for the calculations in part one. And this is because I didn't initially have the mass of the black hole, so I wasn't able to calculate F net through the gravitational force equation. So instead, what I did was I used dp/dt to calculate F net and its components, and then use the gravitational force equation to solve for mass. So what if instead of wanting to like escape the orbit of the black hole, I wanted to orbit around the black hole? So I calculated a velocity in order for this to happen, where like the spaceship will orbit around the black hole instead of like escaping. And this was also done through trial and error. And I just tried to find like a velocity that would be kind of closer to the velocity of the planet as well. So like it would stay in orbit of the black hole. So that is the end of my report, and thank you for listening.